Good morning, students. In the previous session, you had learnt about the definitions of the different types of sets. In today's session, I am just working out some problems. So, what are the types of sets we considered? The null set, which does not contain any element, and the finite set, which contains a finite number of elements, infinite set, which contains infinite number of elements, and singleton, which contains only one element. And then, if two sets contain the same elements, we call them as equal sets. If there is a difference of even one element, we say that they are unequal sets. So, A equal to B, the same notation equality we use. If they are not equal, we just cancel it, which we use in general for the inequality of any two quantities. Now I am going to work out some problems. These problems you can expect for a 1 mark question. Now I am going to give you some sets here. You have to find out whether those sets, they may be null set, it may be a singleton, it may be finite, or it may be infinite. So one by one we are considering the problems here. We have to find out to which type does it belong. Now first problem is, the condition would be given, set of odd natural numbers, set of odd natural numbers divisible by 2. Divisible by 2. Look here, I am considering the set of odd natural numbers. Odd number means 1, 3, 5, 7, etc., etc. Natural number means I have to take only the positive numbers. Divisible by 2. You know that any odd number, we can, divisible means any number you can divide by 2, that's not the question. Divisible means the number should be exactly, that is, we have to get the remainder to be 0. Then only we say a number is divisible by 2. That is, suppose you take 10, you can divide that 5 times. Suppose you take the number 9, you can divide 4 times, there would be the remainder 1 there. So we don't say 9 is divisible by 2. When 10 is there, no, you can say it is exactly divisible. So divisible means it should be, the division should be complete, the remainder should be 0. So the set of odd natural numbers divisible by 2. In such problems, you need not write the set here and find out. Just give the reason, because only one sentence you can give the reason. So how do you write this one? What type of set it can be? It is an empty set, because what's the reason that you have to give? Suppose they ask you justify. The reason this should be given is no odd number is divisible by 2, right? The answer is it is a null set, or it is an empty set. You can write like this also. It is a null set. Now what is the reason you have to give here? Since no odd number is divisible by 2. Divisible by 2. Okay, you have to give the reason here. So it is a null set. Why it is a null set? Suppose they ask you justify your statement. Then you have to write, since no odd number is divisible by 2. Or you can write, odd numbers are not divisible by 2. No odd number is divisible by 2. That can also be written in another way. Odd numbers, they are not divisible by 2. So you have to give the reason. You need not write the set here. I mean, writing inside the flower bracket, it is not necessary, because when it is given in the form of a sentence, the answer can also be given in the form of a sentence. Next is the set of even prime number. Set of even prime numbers. Now, just now I gave an example for a singleton. See, prime numbers, what are the prime numbers? 2, 3, 5, 7, 11, 13, 17, etc., etc. It is an infinite set, as you know. You observe from 3 onwards, all the numbers are odd numbers. Only 2 is the only one even prime number. Therefore, you write set of even prime number. That means this is equal to 2. So what type of set is? It is containing only one element. Therefore, how do you write this one? It is a singleton. It is a singleton. So because it is containing only one element, it is a singleton. Next is the set X. It can be given in this standard form also. A set containing all x such that x is a natural number, x is a natural number and 5 less than x less than 7. See, between 5 and 7 there exists infinite number of real numbers or rational numbers also. But between 5 and 7 we are discussing only about the natural number. After 5 which number comes? 6 comes. So between 5 and 7 how many natural numbers are there? There is only one natural number. First condition is it should be a natural number. Second condition is it should lie between 5 and 7. Therefore, how many elements can exist? Only one element. Therefore, what type of a set is? It is again a singleton. It is again a singleton. Here, take the same example. Suppose I had given here instead of 7, suppose I had written 6 here. Now you observe it is strict inequality. We don't have equality here. 5 less than x less than 6. Suppose I had given like this. That is x lies between 5 and 6 and x is a natural number. Can there be a natural number between 5 and 6? We have infinite number of real numbers but not a natural number. In that case now we have to write the empty brackets. So in the case of here instead of singleton we should write it as a null set. So you have to read the condition or the property or the rule which is given in the set builder form, and according to that one you write the elements, then we will know whether it is a null set or a singleton or a finite or an infinite set. Now next one, the set x, the set containing all x such that x is a point common, x is a point common to two parallel lines. X is a point common to two parallel lines. Look here. What is the definition of parallel line? The lines, a pair of lines which do not meet at all, isn't it? They are called as parallel lines. See, however long you produce, either to the right or to the left, okay, then see whatever may be the length of the lines, now they do not meet at all. That means they do not intersect, they do not meet. That means there will not be a point common to both the lines here. So x, it contains all x such that x is a point common to two parallel lines, or it can also be given as a point of intersection. Common point means the point of intersection. When the parallel lines do not meet at all, there cannot exist any common point at all. So how do you write this one? What type of set it becomes? There cannot exist any point at all which would satisfy the condition. So that means it becomes an empty set. So you have to write it is an empty set. It is an empty set or a null set. But you have to give the reason why it is an empty set or a null set. Since you write the parallel lines do not have a point in common. Do not have a common point also. You can write a common point common to both the lines. No, you can write do not have a common point, or you can write the parallel lines do not intersect. The same meaning is given by writing in two different ways. You can write since the parallel lines do not meet or do not have a common point, or there is no point common to both the lines. No, that can be expressed in 2-3 different ways, but it should give the correct meaning. Therefore, what type of a set is? It is an empty set because we do not have any common point which would be lying on both the lines here. The next is the set containing all the months of a year. The set of months in a year. Set of months in a year. You know that there are exactly, suppose we take our calendar year only. Calendar year, now how many months are there? There are 12 months. So we know the exact number of elements present in this one. So how do you write that one? It is a finite set. How do you give the reason? It is a finite set. This is a finite set. It is a finite set. Finite set because there are exactly 12 elements, or you can write there are exactly 12 months in a year. So we have this, it is a finite set. So we will be considering the example like this. So depending upon how the set is defined, so it may be given usually in sentences, it may be given in sentences, or it may not be given in sentence. Then you have to write using the definition here. First you write how many elements are present. After writing the elements, you can see whether if there is no element, you can write it as a null set. If there is only one element, you write it as a singleton. If there are finite elements, you can write there are finite, it is a finite set. If you are sure about exact number of elements, then if it is containing infinite number of elements, we can call it as an infinite set. Now let me move on to the next example. Next example, sometimes the elements would be given directly, that is in the roster form. You take this one, 1, 2, 3, 4, dashes are put like this. Can you say exactly how many elements are present here? Not possible, because we have just written 1, 2, 3, 4, etc., etc. If the last element is given, we can count the elements and say it is a finite set. Whereas here we do not know the exact number of elements. This is nothing but the set of the natural numbers, which is denoted by capital N. Therefore, how do you write this one? It is an infinite set. It is an infinite set. What is the reason here? Since it contains infinite number of elements. Infinite number of elements. We do not know the exact number of elements, therefore we call it as an infinite set. Now, the same way, by making some small change in this one, the same set I am considering. Now I am putting dashes here, 98, 99, 100. Look here, the difference between the previous and this one. In the previous one, I had put dashes and I had not written the last element here. Therefore, we did not know how many elements exist. Therefore, we took it as an infinite set. Here also, I am considering the natural numbers only. Starts with 1 and ends with 100. So, I am sure about how many elements are present. How many are there? 1 to 100. That means that it has got 100 elements. Suppose I can, if you denote the set as A, I can write NA is equal to 100. Now what do you call this set? It is a finite set. Okay. So how do you write this one? It is a finite set. It is a finite set. Finite set. Give the reason. Because there are exactly 100 elements. There are exactly 100 elements in the set. There are exactly 100 elements in the set. Therefore, we call it as a finite set. So, usually they ask you, find what type of set is it, and then justify your statement. That means why you take it as a finite set, why you take it as infinite set. The reason should be specified. The next is the set of positive integers. The set of positive integers greater than 100. Set of positive integers. Set of positive integers greater than 100. All the numbers should be more than 100. But I am not set the last element of this one. So how do you write this one? More than 100 means we have to start with 101, isn't it? The two positive integers, 101, 102, 103, 104, etc., etc. Because I have not said anything about the last element of this one. So all the we should consider only the positive integer, and those integers should be strictly greater than 100. So 100, and it starts with 101, nothing but the natural numbers here. But the first number being 101, we do not know the last number. I mean, we do not know the exact number of elements. So what do you take this for? It is an infinite set. So I have to write it is an infinite set. It is an infinite set. Okay. So this is how you have to write. So looking at the elements only, we can say whether it is a finite element, finite set, or an infinite, or a singleton, or a empty set. Now take the next. Sometimes it is given like this in sentence. Sometimes it is given in the roster form. Let me take the next one. The set of prime numbers. The set of prime numbers less than 100. The set of prime numbers less than 100. Now, what is the first one? 2. Next is 3, 5, 7, 11, 13, etc., etc. Okay. Now, the last number would be, say, 97. Last number. See, these elements need not be written. Less than 100 means it is fixed. We start with 2, and any number would be less than 100 means we will be having exact number of elements belonging to that one. You need not write all the elements here. If you write, it's well and good. Or else, looking at the statement here, we can say, see, the set of prime numbers less than 100 will be certainly a finite set, because we will be knowing the exact number of elements that would be belong. You need not count and write also here less than 100, because there is a limit here. Up to 100 we can consider means within 100, no, it will be certainly, we will be knowing the exact number of elements. So it becomes a finite set. So you have to write the reason it is a finite set. What is the reason you go? Since we know the number of elements, exact number of elements that is present in the given set. So read the statement properly, or read the which is given in the set builder form. Read it properly, then you can write. Next is the set of lines. The set of lines. The set of lines parallel to the x-axis. Parallel to the x-axis, or it can be given parallel to the y-axis also. Set of lines parallel to the x-axis. Let me draw this one. Now this is x-axis, this is y-axis. This is the origin, isn't it? Now set of lines parallel to the x-axis. How many we can draw? Here we can go on drawing, isn't it? Above the x-axis, or it can be below the x-axis. There is no limit at all. See, we can write any number of, we can draw any number of lines parallel to the x-axis. So this becomes an infinite. Of course, I have given little space here. In between also we can write so many lines here. So the set of lines parallel to the x-axis, or it can be given parallel to the y-axis also. Even then it would be an infinite set, because you have to give the reason, since we can draw infinite number of lines parallel to the x-axis, or whatever it is given parallel to the y-axis also, depending upon how it is given, whether it is x-axis or y-axis, or it may be given parallel to any line also. Need not be always x and y axis. Parallel to any line, above that line, below this line, you can draw infinite number of lines parallel to that one. Therefore, it becomes an infinite set. Now, the set of animals living on the earth. Set of animals living on the earth. Living on the earth. It would be a very huge number, no doubt. We can take the census of the elements, census of the animals throughout the world, on the earth we are saying. Therefore, see, if we take considering each country, each continent, we can find out exactly how many animals are there. Animal in general, okay, in general. So all the animals, you can take the census of the animals of all the continents on the earth, and we can take the total. It becomes a huge number, no doubt, but still we call it as a finite set. The reason is we will be knowing the exact number of elements. That is the definition of a finite set. See, suppose you take the population of a country, population of a continent, population of the whole world. Certainly it is a very, very, very huge number. Still it is a finite set. What is the reason? Because we know that it can be, we know the exact number of elements here. That is why exact number of elements, therefore, we can say it is a finite set. That is the reason we give for it, we consider that to be a finite set. If the number is a very huge number, very big number also, we take it as a finite set. The reason being because we can know the exact number of elements. The next problem is set of the numbers which are multiples of 5. Set of the numbers which are multiples of 5, which are multiples of 5. Here I have not said anything about positive number or negative number. Even if you take negative numbers also, it is divisible. Multiples means by 5 you have to divide. You could divide those numbers by 5. What's the first number you can take? 5. 5 ones are 5. 5 twos are 10. 5 threes are 15. So we take all these numbers to be the multiples of 5. Or you can go on the negative side also. 0 you can take. 0 is divisible by 5. Then minus 5, minus 10, minus 15, minus 20. All of them now you can divide by 5. So we say these are multiples of 5. That means what you take for this one? It is an infinite set. If I had given some restriction between 0 and 90, 0 and 100, or between minus 10 and plus 10. So if I had specified a limit for that one, then it would become a finite set. Whereas here, I'm just saying the numbers which are multiples of 5, that means automatically it becomes an infinite set. Now, this is how you have to find out. So, sometimes it is given in the roster form. That means the exact number of elements would be given. Sometimes it is given in the set builder form. So in whatever way a set is represented, looking at the elements, number of elements, you can come to the conclusion what type of set it is. No element, it is a null set. One element, it is a singleton. And finite elements, finite set. Infinite elements, infinite set. Now let us work out a few more problems where I will be giving you two sets, A and B. You should say whether they are equal or unequal. Now, let me take the first set. Set A is containing A, B, C, D, 4 elements. Set B contains B, C, A, B. Look at the elements. We are having 4 elements in both the sets. A, B, C, D. Here, these same elements are there. Order is different. So, what can you say? Are they equal or unequal? Certainly, they are equal. Why? What's the reason? Since they contain the same elements. Don't say same number here. They contain the same elements. Therefore, they are equal to each other, or A and B are said to be equal sets. Now, take another example. Here, I am giving the elements of the set A in the roster form, that is 2, 4, 6, 8, 10. What are these elements? They are even numbers, 2, 4, 6, 8, 10. That is, it contains the even elements between 1 and 11. I can say that. Next is B, the set B contains all x such that x is a positive even integer, less than or equal to 10. positive even integer less than or equal to 10. That is, A is containing 2, 4, 6, 8, 10. 5 elements are there. How is B defined here? See, that is given in the roster form. You know the exact elements. It is given in the set builder form. B is containing X, all X, such that X is a positive even integer less than or equal to 10. That means that, see, it should be positive, it should be even, it should be less than or equal to 10. So equality is also there. So what are the elements here? First one is 2, second is 4, third 6, 8 and 10. You observe A and B, both of them are having the same elements here. So what is our conclusion? Therefore, A is equal to B. That means that A and B are equal sets here, or A is equal to B. Now, let me take another set. A contains the elements 4, 8, 12 and 16. B contains the elements 8, 4, 16 and 18. 8, 4, 16 and 18. Look at the elements. Both of them are containing same number of elements. Are they equal? See, 4 is there, 8 is there, 16 is there. But A is having a number 12, B is having 18. So, though the same number of elements are there, not the exact elements here. So, what is our conclusion? A is not equal to B. Again, it's a 1 mark question only. A is not equal to B. Suppose they ask you the reason. How do you give the reason? They do not contain the same elements. A is not equal to B. The reason is they do not, the sets A and B do not contain the same elements. Therefore, they are unequal sets. They are unequal sets. Now, let me take another set here. Set A contains all X such that X is a multiple of 10. X is a multiple of 10. X is a multiple of 10. This is the first set. I am giving that in the set builder form. That is a rule method. And the set B contains, it is given in the roster form. 10, 15, 20, 25, etc. Now, look at the two sets. It is in the set builder form. This is in the roster form. We know the elements 10, 15, 20, 25. What type of numbers are they? You can divide all of them by 5. That is the multiples of 5. The set B is containing multiples of 5. Among them 10 and 20 we are having. They are multiples of 10 also. They are multiples of 5 as well as 10. Whereas the set A, according to the definition, what are the multiples? 10, 20, 30, 40, etc. Isn't it? Here we are having only multiples of 10. Here we are having multiples of 5. Okay. So you can clearly see that those elements are present here. But these 15, 25, they are not there. That means the sets A and B are not equal to each other. That is multiple of 10. This is multiple of 5. Therefore, you have to write A is not equal to B. Now, one more problem and I will be concluding the session here. Now, the next problem is the set A contains only 2 elements, 2 and 3. Now, set B, I am defining or I am representing the set in the set builder form. It contains all X such that X is a solution. X is a solution of the equation. X is a solution of the equation. Solution of the equation x square plus 5x plus 6 equal to 0. So, the set A contains 2 elements. It is given in the roster form. We know the exact elements. Set B is defined like this in the set builder form. X is a solution of the equation x square plus 5x plus 6 equal to 0. Now, what type of equation is this one? You are familiar with that one? It is a quadratic equation. That means that first let me solve, because we are interested in the solution of this one. Now the procedure you know, we have to split the middle term in such a way, the sum should be 5, the product should be plus. How could you do that one? X square plus 3x plus 2x plus 6 equal to 0. That is 3 2s are 6, 3 plus 2 5. So grouping them, taking out the common factor, we have x into x plus 3 plus 2 into x plus 3 equal to 0. That is x plus 2 into x plus 3. What I am doing actually is factorizing. I am not using the formula. That means that x is equal to minus 2 and x is equal to minus 3. Therefore, the set B is containing the elements minus 2 and minus 3. See, numerically they are same. 2 and 3, here also 2 and 3, but that is, they are plus 2 plus 3, these are minus 2 minus 3. So what is our conclusion? A is not equal to B. That means they are not equal sets. So, for a 1 mark question, you can expect like this. Given a set, you may have to find out whether it is finite, singleton, infinite or null set. Or when 2 sets are given, you must be in a position to find out whether they are equal sets or unequal. If it is given in the roster form, we will not be having any problem. If it is given in the set builder form, write the exact elements here and find out whether they are equal or unequal. Okay. In the coming session, we will be considering the next topic of the same chapter. Thank you.